with adding of roots, you're going to simplify each of the roots and then add them together if you can. And we'll talk about whether or not you can add them here in a second. So you simplify root 45. And we have a pair of 3's. And this would be the same whether it was cube root or fourth root or whatever, depending on the index. You would circle pairs or groups of 3. I see I have a pair of 3's. So I'm going to take that out and multiply it by the 3. So 3 root 45 is equal to 9 root 5. Square root of 80, simplified. Kind of a mess. I get 4 2's and a 5. Whatever way you do it. So I bring each pair of 2's out, multiply it times the 5, giving me 20 root 5. The green dot signifies my lonely terms in this problem. And then for 4 root 20, I have 2 root 5. So 2 times 4 would be 8. So after simplification, I have 9 root 5 minus 20 root 5 plus 8 root 5. To add or subtract roots together, the root part has to be a perfect match. So root 5's can be added together. A root 5 and a cube root 5 cannot be added together. A root 5 and a root 7 cannot be added together. They have to be identical. When you add or subtract two roots together, you add or subtract the coefficient, but you leave the root the same. So for example, 9 root 5 minus 20 root 5 is negative 11 root 5. The root 5 stays the same, just like if you were adding 2x squared plus 3x squared, we would get 5x squared. The x squared stays the same. Now what we're going to do is we're going to take the negative 11 root 5 plus 8 root 5, giving us an answer of negative 3 root 5. So you simplify the roots and then combine the ones you can. If you can't combine them, you leave them separate and you're done. Or sometimes you can combine a couple of them and then one is separate. You try this one. When you simplify root 12, you get 2 root 3 times the 5 makes it 10 root 3. In the middle, you get 6 root 3 because you had 3 root 3 times 2, making it 6 root 3. For 108, we have 6 root 3 times 6, which is 36 root 3. 10 minus 6 is 4. 4 plus 36, 40 root 3. Questions there? Now let's talk about what happens when we kind of add and multiply at the same time. What's that look like? What do you think we're going to do? Kind of looks like a distributive, a foiling type deal. And you are right. We're going to distribute the 3, we're going to distribute the root 6, and we're going to clean up the mess. So 3 times 2 is 6. And now you have to be careful when you're multiplying because a number outside of a root does not get multiplied times a number inside of a root. So 3 times root 3 is just 3 root 3. You have to be very aware of inside the root and outside the root. Only numbers outside the roots can be multiplied together, and only numbers inside the roots can be multiplied together. If there was one of each, you can't multiply them together. So root 6 times 2 is 2 root 6. And then for the last two, they're both inside the root. So Root 6 times root 3 is root 18. So there's my distributive magic. And now all you do is clean up whatever mess you have. See if you can add anything together or simplify anything. The only thing it looks like I can do is the root 18. I have a pair of 3's. So that's going to become 3 root 2. So my final answer is 6 minus 3 root 3 plus 2 root 6 minus 3 root 2. There's nothing else you can do. The roots are all different, so you can't add them.
Why can't you get 6 and split it up in 6 and 2? Or 3 and 2?
Because it's not under a root sign, so you don't have to simplify it
Not
and
the
move
first
it.
root, the 2.
Because you have to have 6 is 3 times 2, and you would need a pair of numbers to move it out. You try this one. There's my first go-round. And now looking to see what I can simplify. The only thing I can see is the fact that the square root of 9 is 3. Hopefully you didn't type that into your calculator. So that second term is just 6. And that's all you can do. 15, you should be able to see in your head that 15 has no pairs. Because it's a 5 and a 3. Here's a special case. 7 root 2 plus 5, 7 root 2 minus 5. You'll notice they look very similar to each other, except the sign in the middle is different. Does anybody remember what those are called? Kind of. But we had a word for those when we were dealing with imaginary numbers. Started with a C. Conjugates. And when you multiply conjugates together, what happens is the middle cancels. And we used that to our advantage when we were dealing with imaginary numbers and we had to get rid of the imaginary number. Okay? And the same thing kind of happens with roots. You'll notice in this case, the middle will go away. And what's 49 root 4 equal to? 98. So using a conjugate is also a way to get rid of a root. Because at the beginning it'll square itself out of there, and in the middle it'll cancel. Which comes in handy with a problem like this.